All right, so let me introduce our speaker. This is Chris Ha. He began his career with Caterpillar back in 2000 as a senior research engineer within the Research and Development Division. In 2004, he created the optimization team, developing and deploying optimization tools and processes to solve various engineering and operational research problems for the enterprise. That optimization team has grown since then quite a bit, and as you'll see in Chris's presentation today, they do a wide variety of interesting things. In 2010, he became the manager of optimization and advanced analytics group within the marketing and digital division of Caterpillar, where he is responsible for providing best commercially viable solutions to business partners and customers by utilizing advanced analytics capabilities such as optimization, computer vision, and telematics. And he is a facility manager of the Champaign Simulation Center in Champaign, Illinois, which is actually located at the research park of the University of Illinois. So they tap into a lot of talent graduated from U of I, and they also work with U of I students as well. Before joining Caterpillar, he was an engineering specialist at Duke Energy, working on structural evaluation of pipe supports, metallic expansion joints, and motor-operated valves. He holds a BS, MS, and PhD in civil engineering from the University of Illinois at Urbana-Champaign, and he's the author of numerous patents and technical publications. And I would say, additionally, that today's talk is going to hopefully offer a fresh perspective, a different perspective in terms of data analytics as industry is seeing it right now. So without further ado, let's welcome our speaker.
Thank you very much. Thank you for the introduction. And it's great to be here. It's actually an honor to be here. So you probably guessed the 90-year-old company, as the title says, is actually Caterpillar. The word embarking really provides an indication that we're in the beginning of the journey. So today's goal is to give you some perspective from the industry side. But, I remember when I was a graduate student, I would come to seminars like this, and I would only understand 50% of it because there are so many equations. Well, to tell you, I have no equations in my presentation today. So my goal is to not to fall asleep. It's a 1 o'clock seminar. It's challenging, and also make you understand each slide as we go through these things. That's my goal. So hopefully it will be informative. Okay? So in order to tell you why we're on this digital journey, it's important for us to tell you about who we are and why we're on this journey. Then I'll follow by some activities that we're doing in the digital space as an example. So the meat is in the example side. So if we can get through, top 3 topics early, then I'll be able to give you a little bit of examples. And I can stick around a little bit after the seminar if you have questions afterwards. So let's see how it goes. So who we are. So you probably have guessed that we are the world's largest manufacturer of construction and mining equipment. But I don't know how many of you also know that we're the leading manufacturer of diesel and natural gas engine, as well as the industrial gas turbine. Okay? In 2015, we had about $47 billion of revenue, actually quite a bit down from the 2013 peak at $60 billion. Our percent of a sale outside the U.S. is about 60%, and because of that, we're U.S. one of the leading exporter for U.S. at $13 billion. We have about 100,000 employees globally, and more importantly, we have 3 million products that's currently working anywhere in the world. And we're a leading indicator for the business size, so we're actually Dow 30 index company. And all the facts that I've given you is related to Caterpillar, but we actually have a great partnership. So most of the product that we sell is through the dealer. So we have a great dealer network. And we have 175 dealers in 182 countries. And the estimated net worth of the dealership is about $23.4 billion, which we think is a competitive advantage compared to our traditional competitors. And we also have a great supply network at 28,000 plus globally. Industry that we serve are mainly divided into three different categories. Resource is mostly mining, then the construction, then the energy and transportation. Energy mostly, we're talking about power generation, diesel engine, the generators. And then we also provide engines in the transportation side. We're also in the rail business. So Progress Rail, which is one of the companies that we own, is doing the services as well as providing the engines for the train. So we have about 300 different product lines that we make, but it's very, very diverse. To give you a little bit of perspective on the size. So this is the biggest truck that we make, 797, and compared to the smallest machine that we make, which is skid steer, right next to each other. A little bit more fact about it. This big machine truck is sold at about $5 million, and each payload is about 500 tons. And the diameter that you see of this tire is 13 feet in diameter. Okay? And because it's so big, we cannot pre-assemble it and move it. So we have to go to these are usually used in mine site, so we have to take all the parts to the mine site and assemble it there, and it actually dies there. So because of that, it takes about 20 days to assemble. Okay? However, this is not the biggest machine that we make. It's the biggest truck that we make. Biggest machine that we make is Dragline 8750, and size comparison. And you see the truck that you saw previous slide is right here. And this is it's the $80 million machine. And you can compare that with the 747 Boeing and the building that actually designs this machine. Okay? You're probably interested in our, investment in R&D, research and development. You guys are engineering students here. And for a manufacturing company, we actually invest quite a bit, about 3 to 3.5% of our total sale. So last year alone, we spent $2.165 billion in the R&D. And we're big on patents. So currently we have 16,000 patents worldwide. And last year alone, we were granted 1667 patents. So all this investment we put in R&D really enable us to be innovative on our product. And here's 10 different ways of our Caterpillar product had changed the world. So back in 1904, when everybody was doing cultivating using horses, we introduced steam-powered track-type tractors so they can be more efficient. Then we had our first motor grader. We can have a smoother road. And the same year, we also had our first world mass manufacturable diesel engine. Then number 4, low ground pressure undercarriage, so we can actually work in extreme weather like North Antarctica. Then in number 5, this is actually a symbol of our innovation, elevated sprocket of the bulldozer that actually made it much more efficient, but more importantly, operator likes a smoother ride. So there are a lot of operators that actually prefer our machine compared to our competitors. And number 6, actually, if you are driving a bulldozer, at that time, it takes up to 50% of the time turning around. So that's not really that's a really non-value added work. With the differential steering system, we reduce that drastically so they can be a little more productive when they were working. And number 7, introduce our first electric drive that really reduced the fuel consumption. Then 8 and 9 is on the emission reduction, and combine these two technologies, Assert and Tier 4 final, we actually reduced 95% of a NOx over 20 years, which is the emission that is produced by the diesel engine, as well as soot. We were able to reduce that by 95%. And number 10, recently, we introduced a hybrid excavator that had reduced more than 30% of the fuel consumption, and it actually won the Edison Innovation Award that year. So, we have a great products, right? And we can innovate, okay? So why go digital? And more importantly, why now? So are you aware of maybe any great companies that had a great product that can be very innovative and create a lot of invention, actually does not exist anymore or go bankrupt?
Kodak.
Kodak. So I'm glad that you brought that up. So Kodak is a great company. They've been around 100 years, right? They've invented a lot of things. In fact, 1975, way before we are aware of a digital camera, right? They invented digital camera. But guess what? They decided not to commercialize it because their core business at the time was film sales. So this was going to disrupt their own core business model, so they decided not to pursue it. What they didn't know is that if they don't do it, somebody else is going to do it and disrupt their own core business. So in 2012, they actually went bankrupt. Right? So speaking of a bankruptcy and speaking of a lot of these great companies that are no longer around, what's usually the lifespan of companies? Okay, how long are they going to be around? According to Salim Ismail, okay, the lifespan of these companies is getting shorter and shorter. S&P 500 in 1950 used to be about 60 years. Now it's only 18 years. It's getting shorter and shorter. These are very disturbing facts for companies like Caterpillar. How long have we been here? 90 years. There just simply aren't many 100-year-old companies in S&P 500 or Fortune 500. And if you study those who survived that long, if you look at it, they have two main ingredients, how they survive and thrive. One is keep innovating, right? And the other important fact is adaptation to the change of the world or global trend, how they be able to adapt very quickly and create a strategy around the changing world. So let's take a closer look at the innovation and the global trend. Okay?
You said you're only 90 years old, but how come you had a 1904 patent?
1904? So this is official Caterpillar was started that, but 1904. There's you can think of a 100-year-old, but that's the actual origin of the company. That's when they created it. So according to Dragline, so Dragline is a global sort of a consulting firm that actually helps a lot of global companies to be more innovative. There are 10 types of innovation. Okay? Out of that, only 2 types are related to just the product. Okay? Other 4 are related to configuration, and the other 4 is related to customer experience. And many successful companies that actually come up with the innovative new offering usually have 6 to 8 types of innovation types that's embedded into their new offerings. So we've been great at product. We haven't been really putting a lot of effort in other aspects of it. Okay? So what about the global trend? Okay, so according to PwC 2014 article on the Global Annual Review, these are the 6 global megatrends we cannot ignore. So take a look at this and see if you guys agree. Probably 2014, this is pretty agreeable. Okay? Can you think of those things that maybe it's not true? So let's take a look at 2 of these things. Okay? So a few years ago, China was growing at double digit, right? Now, slowed down, maybe 7%. Quite a bit. 2 years ago only, crude oil was what? $104, $106 a barrel. Now it's $40. Back in 2013-14, I don't think anyone have guessed the $100 barrel can go down to $40 a barrel now. Right? So Caterpillar, including many companies, bet on these trends and created their strategy around it. And because of that, Caterpillar in particular, we oversized. Yeah, we created a lot of manufacturing facility. we're definitely in the resource industry, right? We thought it was going to be really big. So these days, as you can see that our revenue, as I mentioned, our revenue has been going down. So we had to do a lot of restructuring. And that's the purpose that we're doing a lot of restructuring. Okay, let's take a look at some other trends. These two, especially in the technology stuff. So certainly 2 years ago, this was the trend. Now, it's not just the trend, it's actually accelerating. Right? So on the hindsight, should we have bet on the other two or this one? I mean, if on the hindsight, we should have probably think about the technology trend, more emphasis on technology trend than the other one. Right? So let's take a closer look at the technology trend, especially the digital. So obviously, it's all around us, right? Digital technology is changing the world, the way we do business, right? So in this industry sector, let's say that, all these things used to require a lot of physical assets, physical location, physical materials, etc. Now it's all been replaced by the tech companies, right? Why? Because the cost of replicating digital materials is effectively zero. If you think about internet startup company in 2000, it costed $5 million to start up. Now, $2,000. Basically, with your piggy bank money, you can come up with a startup internet company. So what about the industry that Caterpillar serve? Okay? I mentioned about the industry that we serve, right? Well, we think it's got a heavy capital investment, okay? Extensive domain knowledge that we have to create over the years. And because we're a B2B business, right, that we have a great relationship that we accumulated over years. So we always thought that it's like a high barrier of entry. Okay? Is it really the case? Is it really the case? Not sure. Because customer is not really in a business of buying our machines. Customer is a business to doing the work. Either moving the earth, okay, generating power, or building buildings, right? They're buying our machine as just a way of doing things, doing their work. Yes, they buy our machines and they put a lot of investment in it, but they also put a lot of investment solving their own problem. In fact, they hire a lot of consulting companies to solve their problems. Billions and billions. Okay? So, we have a traditional competitor that sells a similar type of stuff. We also have what we call non-traditional competitors. It could be a consulting company or tech company that actually solves the problems for our customer. They can come between us and our competitor, and us and our customers. So, what about our competitions? What are they doing? That's why they're teaming up to leverage IoT and big data. Try to do the same thing that we've been doing. So, now, does it make sense why we're going to digital? I mean, if I were the executive, we would have gone to digital a long while. Actually, we've been on this digital journey for a while. A lot of pockets of success, a lot of different divisions doing things. But until earlier this year, officially announced as this is the number one focus that Caterpillar is going to be doing, is to leverage digital technology. So at BAMA, which is the 2016, earlier this year, which is the biggest construction, expo in the world, we announced that the Caterpillar is on the digital journey. And here's a video from that. So it's going to be loud, so make sure that we have people stay awake. So I'll show you a little bit about it.
We live in an age of smart, an age of smartphones, smart appliances, and smart homes. An age where connected devices are improving lives and revolutionizing work. From job sites to generators to machines of all sizes, this is the age where iron flexes its intelligence. where the machinery that enriches lives, powers businesses, and builds communities is given the connectivity to be even safer, more efficient, and more productive. This is the age where our industry evolves, the age where job sites become their own networks, where entire fleets speak the same language, and where work gets done faster with fewer setbacks. This is the new era of smart, and CAT is built for it. Welcome to the age of smart iron.
So the title that we put it as Digital Journey is Age of Smart Iron. Obviously, we have a great product, so I want to make sure. So we want to put the digital technology around our great product to solve our customers' problem. And probably in the video, you probably saw some glimpse of some of the digital technologies that are being used, right? So we've been using it, but this is official launch at an enterprise level, that how we're going to focus more on the digital. So while I mentioned about that Caterpillar's not doing well, we are definitely divesting in some of the area that's not doing well, but we're investing those money into the digital technology. So I stole this. Okay, yes.
Just a quick question. From the video, it seems like you're using technology to enhance your equipment and the ability for that equipment to work with other equipment in the job site, but not to necessarily help manage or improve the customer experience with that.
So if that's how it came out, probably maybe we didn't do the right job on the video, but we do enhance our video. That's one aspect of it. But if you're connected, okay, you can create a lot of the data gain insight from the connected assets, so we can actually provide the information to our customer to solve their problem. So that's the model. So this particular slide, I stole it from the McKinsey as they talk about the digital journey. And these are 4 successful criteria or 4 aspects of the dimensions that we can be successful in the digital journey. So number 1, we have to have a great strategy. And then the digital could mean a lot of different things to a lot of different people, but what do we mean by strategy, and what's our strategy around it? Organization and talent. Okay, so another big challenging, how are you going to organize in a way that can be executable and attract the talent? And culture. To me, this is the biggest challenge for a 90-year-old company. We've built all this culture over 90 years. It's really difficult to undo things and redo it. So we have a little bit of way of how we go about sort of changing the culture. I'll tell you a little bit about it. Then, of course, the capability. We're talking about connectivity. We're talking about analytics and customer experience. Okay? So I'll go into each one of these things. So age of smart iron, the strategy. So it just sort of alluded to your questions. So we're talking about, so we're a great product company, right? That we're going to focus on now more of a solution. We have a product, but also we're going to focus on solution. So digital solution designed to transform productivity, efficiency, and safety at job site, ultimately improving profitability for our customers. And I know it's a one statement, cannot be strategy, but you can see it in a high level what we're focusing on. And it really works well with the operating model of a seed, grow, and harvest. So if we have more assets out there that can be more connected, we have advantage of providing better solutions to our customer than our competitors. Okay? The second, organizations and talent. Okay. Organizations, so in the last couple of years, we actually formed a new organization. We also acquire a lot of other organizations like analytics companies, sort of absorb that. So as I mentioned, we divest something, but we also invested in some of the analytics companies to bring it in. Our current existing companies, we actually create a tech-enabled solution, and focus of this group for each industry is to come up with the technology that will enable for us to provide better solutions directly to our customer rather than focus on product development. Okay? Then the third one that we recently formed, a Caterpillar Venture Capital. Now they're located in California by the Silicon Valley, and their purpose is to really start thinking about partnering with a lot of startup companies in the digital space. And because of that, we partner with a couple of, I think 2 or 3 already since the formation about a year ago. Now, talent acquisition is a big challenge. It's not just for us, okay? So we used to have, we still have what's called engineering professional rotation program, where we hire these engineers and they go through the sort of a training for the first 15 months, creating a network, understanding what our business is. We've created those same type of things for analytics and IT space. And same thing for practicums or intern programs. So where I'm located, Champaign, we leverage a lot of the U of I students to actually come and work during the semesters. But used to be only engineering, now analytics and IT with a lot of computer science and computer engineering people. Now, the challenge that we have is not just, as I mentioned, by us, but other manufacturing companies. So I'm going to show you a video that we're facing, okay, as we try to do on the digital journey. So this is one by GE.
I heard you got a job as a developer.
It's official. I work for GE.
What?
Wow.
Yeah.
Okay.
Guys, I'll be writing a new language for machines, so planes, trains, even hospitals can work better. This is... Oh.
Sorry, I was trying to put it away.
Got it on the cake.
So you're going to work on a train?
Not on a train, on trains.
You're not going to develop stuff anymore?
No, I am. Do you know what GE is?
So there's a couple of other videos like this. But so, when you try to go out in the trying to recruit people, let's say computer science, and we have a nice, toy model next to it, right? Try to talk to these people. They don't come, right? They don't come and talk to us. So recently what we did is that we have some brochures. We have an iPad on top of it, and we use augmented reality. So if you put it on it, this thing comes alive. Once we have those things, then they come and talk to us. So these are little things that we do, try to make the engineers and people there and working in IT understand that we are trying to be, advancement in the digital space as well.
So why did you partner with like Google or IBM or something?
Yeah, that's
what was the reason for doing it internally?
So we are doing both. So recently, I'll tell you a little bit about on the next slide. Actually, I go to the next slide right here. Okay, so culture is a big challenge for us, as I mentioned, right? So our motto is think like a customer, act like a startup. Think like a customer is an easy part. We understand our customer. We have a lot of people with the customers that can provide us. Act like a startup is going to be very, very difficult, right? Everything has to be fast. There are a lot of hurdles, and I'm sure you guys worked with the UTC, probably going through the same thing. So how we try to change the culture is it can't really change it from internally. So we're trying to create not division, but some organization that are nearby the startup locations like Champaign and Chicago, and let them become more of internal startup companies. And then we're one of them. Okay? And another one is that we partner with other companies. There are startup companies. So Uptake, for instance, they're an analytics company. They were the number one startup company in 2015. They're Chicago-based, about 500 people. We partner with them to specifically work on predictive diagnostic tools through a mobile interface. Okay? Then another partnership through the capital sort of venture is this peer-to-peer equipment rental startup. Now, the trick with why not just to partner with the Google? It could, okay? There are a lot of companies that are trying to do the same. It's about the whether business model and the terms that we can partner make sense or not. We think that partnering with a certain specific companies or buying it will make sense, and also internally develop something that's dear and heart to us about our equipment. We can actually, combination of those things will be very beneficial. So both internal development and certain things, as well as the partnering with the analytics company.
Do you think there's an inherent conflict between the digital and the Aaron?
Yes. Well, so yeah, obviously there's some cultural differences, and how we try to do this both is going to be challenging. But eventually what we think is that if we just stay on the iron-based company, we feel like we're going to die. We're going to be obsolete. So we have to make transition. It's going to take time, okay? But we have to transition. I don't know whether we're going to be totally just a solution company. We're still going to have a great product. That's our base. We don't know what's going to be in 50 years from now. But at this time, just creating a great product is not going to survive. I don't think we can survive doing it that way because there's a lot more pie. I didn't mention this, but our pie of industry opportunity is actually shrinking. We're doing it really well as far as the percentage of a market that we have for our industry. We have actually been increasing. But the entire pie has been shrinking as far as selling the product. So we have to go beyond selling the product, meaning that there's a lot of a solution providers that's out there that we feel that we can do better if we can bring up our digital space. So they're like a consulting company. They actually don't have a lot of domain. They say, just give me the data, I'll find a solution for you. But guess what? We can do the analytics. We can find the solution, but we know more about the domain expertise. We've been in this business long, much better. And we've actually proven that with some of the sort of challenges is that our customers gave us. Recently, they gave the same data to the McKinsey, Caterpillar, and GE, and we've actually won, trying to find the solutions based on the data that we have.
My point is, why do you want to keep the age of smart iron? Why do you need to keep the word iron?
Because of how we want to start the digital space is trying to connect this, assets that we have first.
Asset, right?
Yeah.
But you can use, say, for example, the synthetic fiber is strong now to replace iron in some sense.
Right. So to me, I think it's going to be a stepwise, right? It's a too big of a risk to go completely different right at this time. So who knows? 20, 30 years from now, we might invest in that. But what we can do, we can provide the direct impact to our customer is, right now we can't even do around our own machines all the digital technology. If you jump too much from that, this is my opinion, there's a lot more risk.
I'm not saying we should put a synthetic fiber in this, but if you keep that, so kind of iconically seems to be.
Peter,
Sure.
no synthetic fiber is going to dig the hole in the ground, right?
But I think I understand your point. So that's what I meant by how you define your digital, right? You can actually do that. Core business, you're going to change it completely with the digital product. That's not what our digital sort of strategy is about. Right now, we're going to work with what we know the best and the sort of adjacent technology. Let's start with that first because there's a lot less risk and we can do better at it. Okay? It's not going to be like Google X. We're going to completely research on something different. Not yet, at least.
Understand.
So, speaking of capability, so first thing is the connectivity. Which is very important. So we actually have 3 million machines, but currently we have 400 machines that's been connected. Our goal for the next 2 years is to connect all the 3 million assets. Okay. Now, IT is going to be important because you understand that we've been there for 90 years. A lot of legacy system. It's going to be a huge amount of effort in order to completely change this to a new IT. So we're going to have a two-tier IT for a while where, the legacy system, you can still get going because we don't want to disrupt the current technology, but how do you build this cloud network? Okay? So for a while, we're going to have 2 IT systems. Then, and how you harmonize it at the end and later on integrate it. The analytics, now that you have data, now that it's been streamlined, how do you gain insight from these data? So analytics is definitely a capability that we're building. And then a fourth, and maybe most importantly, how do you bring this insight and knowledge to our customers? So the customer experience, how easy it's to get. If you think about it, they're not the best techie company our customer is, right? They're people from the mining and construction side. They're not the first adapter, for instance. They're not going to go buy the first iPhone that's out there. So it's going to be very important for us to be very easy customer interface. Creating that is going to be very important for us because if it gets a little complicated, they're not going to be using it.
Could you just tell us exactly what you did with competing with GE and McKinsey? I'm assuming that is in the analytics area, right?
Yeah.
So what exactly was the problem?
So, they have all this data, and they're basically asking them how we can leverage this data to be a little more efficient in our operations.
Like what kind of okay.
A mine site, actually coal mine site. So
That's dying technology, no?
it is dying technology, but that's the data they had in the coal mine. So we're, and as you mentioned, that we're actually divesting a lot of the equipment that's related to coal mining because that's a dying technology. Joy Global, which is mainly a coal mine that's been bought by Komatsu recently for actually a very cheap price. So here's the example of analytics capability. So I probably have to tell you a little bit about how our value chain, our value works. So our value is measured based on what's called OPAC, which is operating profit after capital charge. So it's got two equations of creating a profit. One is, just one equation. You have a revenue minus the cost, including the capital charge. So if you reduce the cost, okay, with the same revenue, then you'll be able to come up with a profit. Or if you start increasing the revenue, as long as the cost associated with that incrementally increase the revenue is still less, then you're also creating an OPAC, right? So some of the examples that you see, one could be thinking about creating the revenue. Then the other one could be also thinking about how we reduce the cost internally, whether it's through the product development, supply chain manufacturing, etc. Okay? Just think of it that way. So before I tell you a little bit about the analytics capability, I probably have to tell you a little bit about the analytics maturity model. So first, you start with a lot of the data that you have. People like to see what this data tell you. This is basically business intelligence. So just to understand what the data tell you. Maybe trying to create a correlation. Maybe slice and dice in a different way, looking at the dashboard. So these are what's called descriptive analytics. Once you know what the data tells you, the next version is that you know what's going on now. Can you predict what might be happening in the future? So maybe we'll train something with the machine learning. Well, maybe we'll create some regression model. In an engineering term, this can be, think of it as a surrogate model, right? Then you can try to do some simulation and try to predict what might happen. And if you can do that, then you can go into more of an optimization where you can prescribe a certain conditions, right? And try to come up with the recommendation that will meet that condition, which is what's called prescriptive analytics. So those predictive and prescriptives identify as advanced analytics, and the bottom here is business intelligence. And sometimes in this area, a little bit better than this is the diagnostic and prognostic type of things. So our first example is a descriptive and predictive analytics. It's called CAT Asset Intelligence. This is actually a recent, 2 years ago, we bought the company, become part of the Caterpillar. Okay, so this is a real-time asset monitoring, predictive maintenance, and repair, a tool. And I'll just to play a little bit on this.
This is Bob, and this is Bob's ship. To ensure that his ship is sailing smoothly, Bob likes to read his gauges. But Bob's ship has a lot of gauges. And Bob is in charge of a bunch of ships. If something goes wrong on any one of his ships, Bob has to figure out why. And that can mean costly downtime. Bob hates downtime. Bob considered remote monitoring technology that promised to give him all the data from all his gauges. But Bob realized he'd spend all his time trying to figure out what the data really meant and not really get any value out of it. Fortunately for Bob, there's CAT Asset Intelligence. CAT Asset Intelligence gives Bob back control over his data. And that's just the beginning. It combines the knowledge from the technical manuals on Bob's ship with information and advisories for his engines and auxiliary equipment, plus all the past learning from over 40 million machine hours of sensor readings. With CAT Asset Intelligence, Bob can now easily visualize all his key performance indicators in real time. Bob can get the right people, the right information right away. And it makes sure that everybody gets the information in a format that makes sense to them. CAT Asset Intelligence collects data on how Bob's ships are using their equipment and how that affects their performance. It can then make recommendations to manage fuel and energy savings and ensure that Bob can minimize his operating costs. Best of all, CAT Asset Intelligence doesn't just report data. It uses pattern recognition to actually learn about Bob's systems, so it can predict when something is going to fail before it happens. Thanks to CAT Asset Intelligence, Bob can have the right parts for the right ships waiting in the right places around the world. And if something ever did go wrong, Bob can work with his fleet advisor to remotely troubleshoot the issue and get it back online faster. So that means no more downtime for Bob's ships. And maybe a little more downtime for Bob. Take control of your business with CAT Asset Intelligence. Your business just got smarter.
So this system is on our marine assets. We have a similar system for our oil and gas as well as the train. And the one that with the train is actually we partner with the uptake that we have. So next one is actually more on the product development side. So as I mentioned that we collect a lot of the data. So in this case, it's very important for us to know how the operator operates our machine, what kind of application they were using. So we use the data that's coming off from the machine. We actually create a machine learning model in this case that we can use sometimes a rule-based, which is easier to do, but some of the rule-based does not work for certain machines. So that we also use machine learning. In this case, we use the SVM, support a vector machine. And once you get the training set, train the data, as the real-time data comes in, we use that machine learning algorithm to understand what kind of a segmentation or application this machine has done. And all that information is become an input to our product design, whether it's a structural analysis or design aspect of it.
So what kind of data you get? Like mostly error codes or real signals you get?
So real signals that we get. So it could be even strain gauges. It could be accelerometer. Obviously, the GPS. But the pressure, the temperatures, the actual mechanisms.
How fast do you get? Like, what is that?
So some sample rates are, the engine's like a 200 hertz, but a lot of these machines are 10 hertz.
So you actually get the data, do you process on the thing or you actually?
No, we don't do it at the edge. These are, I mean, later on we could, but at this time we just store all these data, we do it offsite. Okay? Because it's not really necessary at this time. There are some diagnostics that we do have to do it at the edge, but not for that one, product development, because we don't need it. These are, so this is a,
Download it continuously?
continuously. Yeah. So this is an example of actually a product prescriptive analytics and a product optimization side. So one of the area I think it might be unique for our group is that when we actually leverage both physics-based simulation and analytics combined. So we think that there are a lot of analytics. When you think of analytics, the analytics is done all in the more of observed data, right? But observed data has basically a number of cases that really doesn't cover entire space. How do you close that gap with the simulated data once it's correlated? So that's where the simulation combined with. So the simulated data, analytics on simulated data. Now this particular one is not that case, but this particular one is more related to the product optimization and simulated space. It's the structure that you see, which is a track roller frame. That when people design, when designer designs it, they think of two aspects. One is the structural performance of it because there's structural components. The other one is actually cost associated with it. And how they do it right now is the designer come up with the design and they toss it to the simulation people. They will do the simulation, even do optimization. Then they bring it back and try to work with the supplier and see whether the cost is good or not. It's a lot of iteration process, usually take a month to month and a half. So why not streamline this process and using the existing tool that they're familiar with? So things like structural analysis, you would use Abacus, okay, which is maybe some of you are familiar with. Things like the cost modeling, we would use A Priority, which has a lot of the supplier databases with the cost model, including the manufacturing costs associated with it. Then we will integrate this using Python, which is scripting language, and come up with the sort of interfaces that the designer or engineer can use. Okay? So we would combine both. You have two objectives, structural performance that has to meet, as well as cost that has to meet. So when you do it, manually, or the current is that they would maybe try out 3 different designs, and they'll try to optimize those things. And when they do, they'll come up with some sort of a criterion in here, and they might pick this one after they try it. But remember, each one of these things takes one month to do. So once you streamline this and combine it together, and once you streamlined it, what we also use is Dakota, which is the optimization tool that's been developed by Sandia. It actually is the one that uses for nuclear program. So, for us, we don't necessarily develop the core technology. We have 10 people that's already developing with a PhD. And so we have a relationship with the Sandia National Lab that we just leverage. Now, not many people use Dakota because you have to do a lot of scripting on their own. There is no good interface. We just create great interfaces that we just leverage all those technology using Python.
Are you happy with it? Because some people have been asking me to use that stuff. So.
Okay, so Dakota is not for everything, right? So we created an interface that you can use all the algorithms from Dakota, but also from other open sources where it doesn't make sense. So we created this interface that we can choose. But the majority algorithm we use is actually from Dakota. So for this one, we actually use MOGA, which is a multi-objective genetic algorithm. So instead of creating just the 3 particular one, we'll create a Pareto front. So once you create a Pareto front, designer can decide whether they like this point, and this point. Okay? So next one is actually Professor Norato worked with us. And I'm here to say that this is one of the most successful ones that we actually won 2nd place in Chairman's Award. So this particular one is actually a welding sequence optimization. So when we have a lot of manufacturing that requires to do fabrication, right? Along the fabrication, you have a subassembly, then has to be put together with the other subassembly to make the bigger system. But when you weld, what do? You put heat, and it's cool, right? And when you cool, what happens? It distorts. So a lot of times, it's distorted too much that you cannot really assemble with the other one. So what they do is that they spend time to correct it with a hammer or some sort of a non-value added process during this assembly process to do the correction so they can assemble it. Well, the weld, for this structure, there might be maybe 14 different welds that's really affecting the distortion. If we can somehow change the sequence of these welds, we can reduce the distortion. And this is actually a truly combinatorial problem, optimization problem, because it's very history dependent. So we didn't use just a blank out genetic algorithm for this one, but more of a specific genetic algorithm. And we come up with the sequence in a way that it will have a distortion that's within the tolerance and still be assembled. So we actually developed this a couple of years ago. We applied it to product model in 5 global facility. And if we expand it to all the product that we have, we're talking about $100 plus million savings. It's a true big impact. Okay, next one is a computer vision. So one of the areas that we're doing is emerging technology. So remember we put a lot of sensors in our machines that we collect the data. Unfortunately, our customer, you try to solve our customer's problem. Customer does not just have our machines. They have our competitors' machine. Well, we can't get the data from our competitors. It's difficult to do. So here, we try to understand at a job site, okay, what the machines are doing with the other machines. So we use computer vision. If you look at the labels on there, you can see that's being loaded, string empty, string load bucket. So we're processing this video using computer technology to understand what they're doing. So think of having this collected for the entire day and understand, okay, we understand based on the statistical data how much time that excavator is spending on the loading, how much time they've been idling. If it's too much of idle, we can actually put another truck to be more productive. If they're too much of a truck being, standing there not doing anything, we need to actually take out, right, the truck that we don't need. So by understanding the segmentation of what they're doing, we can provide our customers some valuable information. Now, on the back there, the excavator, that's actually our competitors, not really ours. So this could be a mixed fleet solution that we can provide. So this is one way to use computer vision technology to understanding our customers and what they're doing and help them out. Now, I'm going to show you some other stuff since we have a little bit of time. So this is actually a job site simulation. So one of the focus areas is how do we improve our customers in a job site using job site analytics, and simulation is one part of it. This is using discrete event simulations, okay? But simulation is only to simulate to understand doing the what-if studies. But once we have the simulation model, which is a virtual proving ground, we actually validate that against the real model. And once it's validated, then we can do a lot of what-if studies. So if they wanted to move, let's say, crusher from one location to another, they have a lot of investment they have to put in. Before they move it, we can actually test it out and simulate this for about 6 months to see what kind of value that they'll be able to get. Before, they couldn't do that. Everything that they're doing is based on Excel spreadsheet. Here, you can actually use the variability, stochastic analysis on top of this simulations to do it. All right. So with that, I have about 10 minutes left. Are there any questions?Ure.
It's great effort. It's very broad.
Yes.
My question to you is that for the core part related to manufacturing, how would this relate to the Industry 4.0 or some of the manufacturing initiatives in the States?
For manufacturing, so I'm only familiar with some of the manufacturing. We're part of the MDII, which is the Digital Manufacturing Institute. One of the biggest challenges with respect to the digital manufacturing is that we have so much legacy system. We first have to get the data, right? It's hard to put all these sensors in existing equipments that we have in a factory without really disrupting the productions that we have. So if it's a green field, a new factory, it's easy. But it's in the current production level, that's going to be really challenging. How do you put all these sensors in the places with the least disruption of the current? So once we have that, we feel like that we have the analytics capability to come up with some. But that's the biggest challenge right now. I would love to benchmark some other sort of companies that gone through the same type of things, how they did that with the least disruption of their current production. Okay? Yes?
Thank you for the nice presentation. You gave us many examples. I wonder, have they already put in the market or they are under test? If they already put in market, what's the reaction of the customers? I mean, what's the review of the customers? Are they willing to pay to buy them because of their better performance and the more expensive price?
Sure, a good question. So some of the examples that I showed you, they're already in production. So like a CAD Asset Intelligence that I showed you, that's actually in production. Actually, you get subscription for it, right? In some areas, they're like a weld sequence optimization. That's actually, it's not to the customer, but a lot of manufacturing facilities are already using it. We're getting the value of it. Now, computer vision side right now is in the investment stage. It's more of a research space at this time. Okay, for let's say structural optimization, it's still on the research that we just approved the proof of concept. I mean, it's going to take a little bit of time going from the prototype into production. There's a lot of challenges associated with it. The trick is how do you create the tool in a way that it can be easily used by the engineers or customers? And that's the trick. That's the customer experience space that I talked to you about. That has to be really good. But yeah, the answer is that some of them that we already have in production, we get the value from. Some of them still in the. I sort of give you the different, breadth of what stage they're in. Besides that, there's different discipline. So.
How is John Deere doing?
So John Deere, frankly, they're better at something. So like an agriculture space, we don't have any agriculture equipment. So they have a great digital initiative in the robotics, especially in the agriculture space. Now, their sort of a competition is not really Caterpillar, but it's people like Monsanto, people like ADM. It's like different types of whether is the data they collected really theirs or is it farmers, So Deere is a great company. They're definitely advanced in the agriculture space. Construction side of it, they're trying to leverage the transfer of the technology they learned from agriculture into the construction, but it's a different animal. Okay.
So it's interesting how this analytics has made some of these companies that were not competitors before all of a sudden competitors because they're getting into this analytics space, right? So just like you said, it didn't cross my mind that Monsanto would be a competitor to John Deere, right? But if they're both trying to mine data about fields that are being cropped, then all of a sudden they're competitors.
Yeah. So one of the things that they focus on is the weather data, right?
Right.
Weather analytics.
It's important for you too, right?
Yeah, it's important. I mean, not as a Deere, and we're sort of in the beginning stage, but yes, our maybe
Especially in the construction.
Construction, which is a schedule-driven company. So those type of things, we actually try to maybe partner with some of the startup companies that in that space, the niche area.
I just want to follow up.
Your ships, the ship thing that you were talking about.
Yeah.
That's very important.
Right.
Who are your major competitors and how they're doing?
Well, as I mentioned, we don't have a one competitor that really covers all the industry that we serve. So like a rail, GE is our major competitor.
They're GE more advanced?
GE, I mean, we like to say we're, I think, pretty competitive. I mean, we have a pretty good Progress Rail that we have is a pretty good. GE is definitely up there. So that's our major competitor. As far as the construction, I mean, we have lots of different competitors. Mining, I think we're definitely best. But the mining industry is shrinking ever so. So we're struggling, obviously, just overall.
Some of Japanese companies are first.
Komatsu. Yeah. So Komatsu is definitely one of our biggest competitors, but in certain sectors, not in the, let's say, marine engines or oil and gas.
Are they more advanced in digital things?
No, I don't think so. I think they've partnered with it. They have autonomous truck. We have autonomous truck. I feel like they take more risk than we do, so that, depends on how much risk that you take. You can actually put it out there, but we don't think that. I think we're not really. We worry less about actually our traditional competitor. We worry more about our non-traditional competitors. That's the focus right now, is to make sure that next year all of a sudden Google is going to say, "Hey, we're going to launch in this space." But I think Google probably have other areas that they're more interested in at this space, but we'll never know, right? It's not all the things that they're successful when they launch a Google X. I understand some of them think that they launched, they actually folded as well. So one thing that I wanted to tell you that our group is very diverse. So I have a group of maybe 30 full-time equivalent people, but they are mechanical engineers, civil engineers, electrical engineer, computer science, industrial engineers, aerospace engineers, economists, operations research, mathematicians. So we look at the problem in a lot of different perspectives. And I think it's really great to work with multidisciplinary people because they look at the problem a little differently. So that we're really fortunate to have this group of people that works really for the same problem, but with a lot of different perspective and background. Yeah.
And I know I'm going a little bit over time, but as I told you, we're building our tech park. Can you say something a little bit about how Caterpillar has worked with the research park?
Sure.
What's the sort of relationship?
So the research park, the location that we're in is actually U of I Research Park. It's one of the most successful, actually a startup-based type of or university-based startup companies there. There are about 90 companies there, about maybe 70 companies, somewhere between 70 and 90, but about 40 of them are startup companies. The other 4 are companies like us. They wanted to sort of focus on a certain area like data analytics and IT, et cetera, robotics. They've come there and really the leverage both the talent and the community they form. And most of these companies hire students from U of I, okay? And so you have right in the backyard of University of Illinois campus, the student will be able to contribute both during the semester as well as the summer as well. And during the semester, these students come here 10 hours a week working for us. And for graduate student, we actually offer both the hourly as well as the research assistantship. So it's different than if you were to work for a professor, where we have a research contract, we just send it to them, the work that you can just work on your office. No, it's different. It's actually, they actually come to our office. They will be part of the Caterpillar sort of experience, but you work on a real industry problem. But by doing that, you get the stipend as well as the tuition's waived. Okay, and because we created the mechanism, actually foreign students can also work, because there are a lot of talented foreign students in the graduate colleges that we'd be able to leverage. So that's.
How does it work? You grant to...
So we actually have a university facility that we pay them, then they pay the students.
And the research park.
Not I think you need to do that.
And the research park is considered campus, so
Right,
since the visa allows you to work.
Right, that they can work in the campus.
Like a tech park is
So it's like 10 minutes away. So there's a bus system that goes around and can work there. And this is a great talent pipeline, right? Actually, Julian used to work as a graduate student, now become a Caterpillar. So that was a long time ago. But when I first worked with Julian, he was a graduate student in the mechanical engineering department. And these days, actually, recently hired high school students locally. The people who took AP computer science, and I gave them hey, can you develop some mobile apps for me? And they did, and then they said, it's being leveraged. So just like a basketball, right? The recruiting getting younger and younger. And these are the student that wants to come to U of I for engineering department. So you go from high school to engineering all the way to. So it's a great pipeline.
All right, let's thank our speaker.